Hello, Matthews Gatos here. Welcome to video 2 of inverse trig functions. In this video, I'll cover cosine, but before I do, let's review sine. So this is a great example here because it takes what we did with sine inverse in our last video and just adds it to the next level. So if I want to find tan of sine inverse of 3 over 5, what this is saying is that I need to find the angle inside here that has, when I take the sine of that angle, it has a ratio of 3 over 5. Now 3 over 5 is not one of our nice angles on the unit circle, and I'm not going to use my calculator because I want an exact value, so I'm going to draw a triangle. So what I'm going to do is I am going to let theta, right here, let theta be sine inverse of 3 over 5, because then I can just simply find out what tan theta is. So I know when I'm doing sine inverse that my angle has to be restricted between negative pi over 2 and positive pi over 2. So quadrant 1 positive rotation or quadrant 4 negative rotation to make the arc sine or the sine inverse function a function. So we have to restrict the domain. So I know that sine is positive in quadrant 1, so I'm going to draw my triangle in quadrant number 1. Now theta has sine inverse of 3 over 5, so look how I've drawn it. Here's my angle. Sine is opposite over hypotenuse, so I know that it's 3 over 5. So I'm going to find tan of that angle. Now to find tan, I have opposite over adjacent. I need to find my adjacent side. Now I know my adjacent side is 4 because I know that one of the Pythagorean triplets is 3, 4, and 5. But if I didn't remember that, I would just use Pythagorean theorem and do 5 squared take away 3 squared is 4 squared. Because I know 5 squared take away 3 squared, that's 25, take away 9, and that's 16. And then the square root of 16 is just 4. So I know my side is 4. So I have a quadrant 1 triangle, sides of 3, 4, and 5. So the tan of sine inverse of 3 over 5 is really just the tan of that angle, and that would just be 3 over 4. So my exact value. So if it's not one of the nice points on the unit circle, you can use a system just like that of substitution. Okay, so let's get into cosine. We're going to do the same thing for cosine. I have the graph of cosine there, 2 cycles. Again, cosine goes between -1 and +1. I know it is a function because it passes the vertical line test. So if I were to draw a vertical line and I were to take that vertical line and slide it anywhere along here, it passes the vertical line test. So I know therefore that cosine is a function. But if I were to take a horizontal line and I were to, let's make that actually horizontal. There we go. And I were to slide it along here, I can see that I touch the graph. Let's try this again. I touch the graph in multiple points. So I know, oh my goodness, what's going on? Let me try that again. Okay, so I know that sliding this horizontal line along here, I touch the graph in multiple points. So I know that the inverse is not a function. So I need to restrict the domain to make it into a function. So again, I want to go from max to min to get the most part of the graph possible. So there are a couple ways of restricting it, but in calculus, the way that we like to restrict it is from max to min to the right of the y-axis so that all my values are going to be positive values. Now I could restrict it from -pi to 0. There's no real good reason why we don't do that. I would say that from 0 to pi, the reason we restrict that is because it includes quadrant 1 angles. Okay, so I have anything from 0 to pi. If I now take that vertical line and along here, this is where I'm restricting it. So if I were to take that horizontal line, there we go, and go up and down. Let me try this again. I'm having technical difficulties here. There we go. If I were to slide it up and down, you can see now on that black part of the curve, I only touch it once. So sine was restricted from -pi over 2 to pi over 2 to get the positive and negative values. Cosine is restricted from 0 to pi. So from 0 to pi just means I'm working in the first 2 quadrants, which really makes sense because in quadrant 1 cosine's positive and in quadrant 2 it's negative. So you hit all of the values by restricting it that way. So just like we did for sine, let's do a graph for cosine. Okay, so here's the graph of cosine from 0 to pi. So I'm going here from 0 to pi. That's the graph of cosine. I want to also graph the inverse on the same graph. So I'm going up here by 0.6s. So here is my graph of cosine. This is in radians, not exact values, obviously, rounded. And then these are my function values, my y values. So I know that when I have an inverse, I take the domain and it becomes the new range. The domain becomes the new range. So I can fill in here 0, 1.6, and 3.1. Now also with the definition of an inverse, the range becomes the domain. So my domain of my inverse will be from -1 to 1. So the range becomes my domain. So I can fill that in as well. Okay, so let's graph those points. I'm going up by 0.6. So I'm going to graph 1 and 0. So I don't know, right about there. And then I'm going to graph 0 and 1.6. So 0 and 1.6. So point like right about there. And then I'm going to graph -1 and 3.1. So -1 and 3.1. So I'm going to say right about there. Okay, so now looking at my graph, I know that it's going to curve this way and then that way. That would be my inverse. Not a very pretty graph, but you get the idea. Okay, so that's what my inverse is going to look like. Again, restricted between 0 and pi. So let's try some examples using our inverses now. So if I want to do cos inverse of -1/2, I'm asking myself what angle between 0 and pi is going to have a cos ratio of 1/2. Well, what has a ratio of 1/2 in general, just like as a reference angle? I know that for cosine being 1/2, I know the point on the unit circle, pi over 3, would be 1/2 and √3/2. So there's the cosine of 1/2. Now, it has to be -1/2. So remember, we're restricting from 0 to pi. So anything in there, and using my cast rule, I know cosine is negative here. So I'm going to take that reference angle of pi over 3 and I'm going to put it into quadrant 2. So I know that the cos inverse of -1/2 is actually 2 pi over 3. So remember again, with inverses or arc cosine, what that really means is that the point -1/2 and 2 pi over 3 is on the graph. Okay, let's try another one here. So cos inverse of -√2/2. So again, ask yourself what angle has a cos ratio of -√2/2. Well, let's just start which one has a ratio of just √2/2. I know that on the unit circle that's pi over 4. That's √2/2 and √2/2. And that is cosine. So let's look at my cast rule. Looking at my cast rule, cosine is negative, so again, it is a quadrant 2 angle. So take that reference angle of pi over 4, putting it into quadrant number 2, I get an answer that the cos inverse of -√2/2 is actually 3 pi over 4. Okay, so let's combine some together now. So in this example here, I want to do the cos inverse of cos of 5 pi over 6. So again, we're always going to work inside out. Remember, all your solutions for cos inverse have to be between 0 and pi. So cos of 5 pi over 6, that fits within our domain restriction. So cosine of 5 pi over 6, well, first of all, I know it's negative because it's in quadrant 2. The cosine has a reference angle of pi over 6. So I know that the point pi over 6 on the unit circle is actually √3/2 and 1/2. So that's the point on the unit circle. So cosine right there is going to be negative √3/2. So then we're going to do the cos inverse of negative √3/2. Which of course is 5 pi over 6. And that satisfies my domain restriction, so I know my answer would be 5 pi over 6. So again, the cos inverse and the cos cancel each other out within that domain restriction. Okay, let's try this one. Cos of cos inverse of 1 over root 2. So that's not rationalized. We're used to seeing it rationalized. So you could write it like this, cos inverse of root 2 over 2, just like that. Okay, so let's see. The point on the unit circle that has a root 2 over 2 is pi over 4. So pi over 4 on the unit circle, that point is root 2 over 2 and root 2 over 2, and there's cosine. So again, I want to stick within my restriction from 0 to pi. So cosine's positive in quadrant 1, so pi over 4 satisfies that. So I'm just going to do the cos of pi over 4, which I know is root 2 over 2. So again, cos and cos inverse, those are inverse operations. They cancel each other out, but you have to make sure that your answer fits within the domain restriction. Okay, let's try another one. So in this one here, I'm going to do cos inverse of cos of 7 pi over 6. So 7 pi over 6, that is not within the domain, because remember, we're restricting our domain between 0 and pi over, or 0 and pi, sorry, 0 and pi. So it has to be there. Now 7 pi over 6 is an angle right here. Now I know that 7 pi over 6, cosine of that is negative. So cosine is also negative in quadrant number 2. So instead of working with 7 pi over 6, I'm going to work 5 pi over 6. The reason being, again, is that cos of 5 pi over 6 is the same value as cos of 7 pi over 6. They have the same reference angle, and using the cast rule, they have the same sign value, sign meaning negative. So it's negative here and it's negative here. So I know that that's going to work. So this is where you can't simply just say cos inverse and cos cancel each other out. They're inverse operations, and the answer is therefore 7 pi over 6. You have to stick within the domain restrictions. So this is really going to be the cos inverse of cos of 5 pi over 6. Now, looking at the reference angle, we're talking about pi over 6. So let's look at the point on the unit circle, pi over 6. So pi over 6 on the unit circle is root 3 over 2.5. And cosine would be root 3 over 2. But 5 pi over 6, it's actually negative. So this would be cos inverse of negative root 3 over 2. And then cos inverse of that, of course, we just know that that is 5 pi over 6. So again, this is a nice example because you can see it doesn't just simply cancel, because you do have to pay attention to the domain restrictions. Okay, so notice when we did cos inverse of cos, those are inverse operations, it's equal to x, but make sure that it sits within your domain restrictions. And then also cos of cos inverse, those are inverse operations of one another, so they undo each other, and you're just left with x, which is a ratio. Make sure that is in between -1 and +1. So this is inverse trig functions for cosine. So I hope that helped. Stay tuned for the next video, which will be on tangent.